chapter. Okay, this chapter is titled Lines. Okay, what's a line? Okay, really? You're asking us? Is that a line? Yeah? How about this? Is this a line? Nope, that's a parabola. Parabola. Okay, all right. Is that a line? Nope. Okay, so a line is a straight, right, drawing with, and it goes forever and ever and ever in each direction. Okay, lines have, how many points are on a line?
Multiple. Infinite.
Infinite. Very good. Infinite. They go on forever and ever and ever in each direction. Okay, lines have slope, meaning, and slope, my friends, it is actually the measurement of how much we rise over a horizontal distance. Okay, now rise in the English language means to go up, but rise in math can be up if you're positive or down if you're negative. Okay, and so look at this. This line, is this line going up or down? Up. We read from left to right in the English language. That one's going up. This one's going down. Okay, it's yelling Tamba. Okay, now this one right here. Okay, what's the slope of this line? It's 0. Yeah, because it's not going up at all over that horizontal distance. And this one, and this line is called a what? What's that line called? Straight? They're all straight?
Straight line?
What? Say it louder.
Horizontal.
Horizontal. It's a horizontal line. Did somebody whisper that in your ear?
Yeah, I heard her. I don't know.
Okay. Okay. All right. Horizontal. Okay. Which makes this line what? That one there is vertical. And we're going to talk about their slopes and all that stuff another day, later this week. So this whole section is about lines. No other shapes. Okay, just lines. And we're going to talk about 4 things with lines. Their basics, how to graph them, how to find their slope, and how to find their equations. Now if we go back and we look at the beginning of every other chapter that we have covered, we have a listing of all the sections that we're going to go over in that chapter. Well, that's not the case here. We have 5 sections in this chapter. It's a very short chapter. We're going to wrap it up in just like a week. Take another test next week in this. Our next 2 chapters, by the way, are over at the print shop, and hopefully they'll be available by the end of this week for you to pick up. I want you to scroll. I actually want you to turn towards the end of this book here, and we're going to look at this visual chart. Look at this. So your visual chart in this chapter is going to be just a 4-box visual chart. And we're not going to base our visual chart off the sections we go over. We're going to base it off of, is the information dealing with basics, graphing, slope, or equations. So then we can go back to our first section here, or that title page, or whatever here. Just in the beginning of this chapter.
Y equals mx plus b.
So again, basics, graphing, slope, equation. Look at section 1. Notice at the top there, in that blue box, it says lines basics. So even though this is section 1, we're talking about basics of lines and plug and chug method, we're going to teach you about the basics of lines, and then go to the next page, and what does it say at the top? It says lines basics. And then we go to the next page, it says nothing, so it continues to be lines basics, but then that page says lines graphing. And sometimes students say, well, Brother Rich, why don't you just organize this chapter into these 4 sections? Well, there is an entire section just about slope, and an entire section just about equations. But basics and graphing, we kind of have to intermingle them. And so there's a couple sections where we deal with both. Okay? All right, let's go ahead and turn to our first page here in section 3.1. Stuff's going to be pretty simple. It's called Basics for a reason. How many of you have ever looked at a paper map before? Raise your hand if you ever looked at a paper map. I would imagine by the time your children are in this class, that answer will be very few people. Okay, GPS has taken the world by storm. We don't look at any mapping system too much except if it's electronic these days. I remember when we used to go on road trips as kids and with our parents, we had Atlas. Big old book. We look up the different states and the highways and where we're going and all that stuff. And mom's screaming at dad, you missed the turn. Hey, kind of funny stuff. Now GPS will just tell you you know, and make a U-turn at the next, you know, stoplight or whatever. Okay. How many of you have ever looked at a paper map? We asked that question. What are the coordinates of Idaho Falls? What are the coordinates of Idaho Falls here? Okay, so we always, this is really interesting. We always list the horizontal coordinate first.
Okay.
So it's B2. And I had some students say, B1.7. Okay? Nope. We don't do the point thing. It's either B1 or B2 or B3. Okay? And so, again, are these exact? No, Idaho Falls is not exact on purpose. So I would write B2 here. Are they exact? No. Okay? When I was on a mission, that's where I really looked at paper maps a lot. You know, you go out and you contact people, and you know they give you an address, and you look the address up on a map, and you never find it, and like it's a bogus address. Okay, and then now and then you get somebody that actually gave you a real address, and then you go and you visit, and they want to show up, right? And then you get to find the golden investigator where they gave you an address, it actually existed, and they showed up, and you're like, oh my gosh, we're gonna be able to teach somebody today. Okay. How many people have ever looked up like street names on a map to find where the street is? Has anybody ever done that before? Okay. And right next to the street will be two coordinates: B-2, A3, E7, or something like that. And with all the little drawings, it's really interesting. You have to sometimes really look closely because the name of the street would be really tiny, and it wasn't exactly on B2. It would be in a circular, you know, radius in around B2. And sometimes you had to really scour for it, okay? On this map here, where would you put Rexburg? Okay, if down is south and up is north, where would you put Rexburg?
Probably E4 or D4.
Okay, so I'm hearing E4 or D4. All right, that's fine. I think there's no really wrong answer here. I might go more this way just a bit. I might go like C4. Okay, let's go C4 on it. Okay. So let's go C4. So if I have this map here, and I have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and so I have 1, 2, 3, 4, 5, and A. Oh, whoops. Am I doing this backwards for this?
Yeah.
Yep. Let's do it. Let's do it the same way. Okay. So we have A, B, C, D, E, and 1, 2, 3, 4, 5, and so we said that Idaho Falls about here. So what do we say we're going to do? C for Rexburg-ish?
Yeah.
Okay. All right, and so where would you put Jackson Hole, Wyoming? Jackson Hole, Wyoming. Does anybody know?
E5. Like F5.
So interesting, yeah, there's an F here. Interestingly enough, it's about right here. They actually triangulate. It's south of Rexburg, so it might be up just a little bit more in here, but it almost makes an exact equilateral triangle. So. Anyways, you pick whatever. There's no right or wrong answers here. But Jackson Hole's more over in that kind of E2, E3 range, okay? All mapping consists of two coordinates. Yes?
Latitude and longitude.
That is hold tight on that. All mapping consists of two coordinates.
Oh, I thought you were right.
A horizontal coordinate and a vertical coordinate, right? And so A, B, C, D was our horizontal. 1, 2, 3, 4, 5 was vertical. And this never changes. And they're always given in that order. Horizontal comes first, always. Okay, that never varies. In the military, what are these coordinates called?
Latitude and longitude.
Latitude and longitude. That's right. Okay, so latitude is your horizontal, longitude is your vertical. And the military, they can put a bomb right through your front fetching north. Okay? That's how precise they are. They measure their latitude and longitude in a measurement called degrees, minutes, seconds. Okay, you thought that was time. It is time. But because the globe turns, all right, that point in terms of how a bomb is being launched, it is moving. It's a moving point. It's a moving target, right? Yes.
So there's, in my town, there's like one of the most advanced ships in the world came, and they said they can put a bomb like literally on your foot.
Yeah.
Like within inches, like
Yeah.
of where the exact of where they want it. Like it's ridiculous.
And they do make mistakes.
From across the world, like they're
But yeah, they
they're
can.
it's ridiculous.
It's pretty crazy. It's pretty crazy. An ordered pair. What's an ordered pair? It's a point. Okay, so look at this. An ordered pair equals a point. And that point always has an x coordinate and a y coordinate. This is going to be your horizontal, and this is going to be your vertical. Always. So if I have 2, 3, X equals 2, y equals 3. You can write that along with this right here, okay? But the first coordinate is always the horizontal. It's always x. The second is always y. It's called an ordered pair because it comes in an order, okay? It's not random, okay? It's ordered. Horizontal, then vertical, always. We cool? Okay, let's turn to the next page, okay? Simple stuff, easy stuff. And have a little bit of fun with easy stuff right now, okay? All right, look up here, please. It says the mapping graphing system in math is called the, do you know what this mapping system is called? It's called the Cartesian Coordinate Plane. And it's called a plane because it's a two-dimensional system, right? It's not a sphere. That would be three-dimensional, okay? So it's the Cartesian coordinate plane. That's the answer up there. What is this axis here called? What's this axis here called? It's called the y-axis, and it has another name. The vertical axis. Okay, so it's the y or vertical axis. Okay, so you have to have both those there. So that makes this axis what? The x or horizontal axis. Okay. All right. So, what are the Roman numerals for? They're for the 4 quadrants that are in this plane. Okay. Let's talk about, there's some empty spaces around 1, 2, 3, and 4. So I'm going to draw this right here. Okay, quadrant 1, quadrant 2, quadrant 3, quadrant 4. Why do we do Roman numerals instead of regular numbering? Okay, because we have regular numbering all over the place in here. We don't want to mix it up. Okay? So I want to know the sign of the points in each quadrant. So think about this. So in quadrant 1, we have positives and positives. Why? Look up here. Because these are all positive and these are all positive. So every point in there has a positive and a positive, coordinate. Okay? So this one would be what? Our x value would be negative and our y value would be positive. Okay? So this one is negative positive. You guys writing this in your workbook here? And then this one here, what would this one be? Negative, negative. Very good. And the last one? Positive and negative. And you can, I guess, hey, do we have to memorize that? Well, if you draw this, it's just going to be there for you. So, exactly, right? Negatives and negatives. Here we have, again, positive and negative. Positive horizontal, negative is our vertical, because our horizontal always comes first. What is the 0, 0 point called? Say it loud. Origin. Yeah, it's called the origin. Okay, if you don't know how to spell origin, O-R-I-G-I-N. Origin. Okay? Because your movement originates from there. We always start at the 0, 0. Okay? When we're plotting and graphing things. Okay, help me real quick. Let's go through this. What are the coordinates of point A?
3, 2.
Okay, everybody. 3, 2. So write 3, 2 there. Okay? Right? In fact, I'm going to just do this. So you guys, you quickly guide me here. We'll go A, B, C, D, and E. So this is 3, 2. Okay, B. Point B is 0 this way, 1. Did you get 0, 1? Is that what you said?
0, 1.
0, 1. I like it. 0, 1. C. Okay? C is what?
Negative 1, negative 1.
Negative 1, negative 1. Very good. D.
3, negative 3.
All right, so we go 1, 2, 3, and negative 4, right?
Yep.
And always horizontal first, 3 and negative 4. If you're making any mistakes, it's because you're doing the horizontal last and the vertical first, okay? Point E,
5, 0.
5, 0. Very good, okay? And then we need to identify, look at back down here, it says, now list which quadrant each point A through J is in. So let's do A through E. Let's talk about the quadrants they're in. Look at point A. What quadrant is it in? Quadrant. There's only 4. 1. B. What's B in?
Would it be in I? 1 or 1?
It's a nut.
It's in none. Very good. It's in none. It's on the y-axis. Okay, if you're on an axis, you're not in a quadrant. So you're in none. C. What's C in? What's point C in? Come on, help me.
3.
3. Okay, let's go through quick. 1, 2, 3. D.
4.
Yeah, D is definitely in quadrant 4. And finally, E.
None.
It is also in none. It is on the y-axis. Is on the what? X-axis. And that's the correct answer. You say none on the x-axis or none on the y-axis. Okay? All right, I want you quickly to plot F, G, H, I, and J. Let's look up here. 2, 5. Do it together. 1, 2, 1, 2, 3, 4, 5. We mark there. I'm not going to mark the screen. Next class won't be happy with me. Okay? G. So did you get F? Did you get F?
Yeah.
2, 5. What quadrant is that? Quadrant 1. Okay? G. 2, negative 3. So we're going to go 1, 2, negative 1, 2, 3. Right there. Is that what you guys got?
Yeah.
Right there. Okay, what quadrant is that? 4. Very good. Negative 3, 1.5. Look at this. We're going to go negative 1, 2, 3, and negative 1.5 can put me right there. You got that?
Positive
Right
1/2.
there. What quadrant is that?
2.
No?
It's positive 1/2.
Okay.
Wait,
Isn't it 1 point? Isn't it positive 1?
Is it positive?
What? I went negative and negative. You're right, it is in quadrant 2. I put it here and you said it was correct.
It's 2.
Okay, look up here. We go negative 1, 2, 3, and then up 1.5 puts me right there. Not down there, right there. And that is quadrant 2. Very good. 0, negative 4. 0, negative 4?
X-axis.
Right there. Or 0, negative 4. Which one? This one or this one?
Y-axis.
Okay, so 0 this way, negative 4 right there. That is the correct answer. What quadrant is that?
Y-axis.
None. It is on the y-axis. And negative 5, 0. Is that going to be here?
It's not x-axis.
It's over here, right? Negative 5, 0 this way. It's right there. And that is also none. It's on the x-axis, right? Okay, hard or easy?
Easy.
Easy stuff. And you have some of that in your homework tonight. And you actually have like a question or two like this on the exam that you take, okay? All right, this is an interesting little segment right here. Let's do this together. Okay? When asked to determine whether the given ordered pair is the solution of the equation, what do we do? Okay? So look at problem number 1. What is the given ordered pair? It's 1, 7, correct? And the equation is y equals 2x plus 5. Y equals 2x plus 5. Okay? So, do you all understand what coordinate is that?
X.
And what coordinate is that?
Y.
So, x equals what? 1. And y equals what? 7. Can I plug those in here?
Yeah.
Yep. So, I can put 7 in here. I can put 1 in here. And I have plus 5. 7 equals 2 times 1 is 2 plus 5. 7 equals 7. Check that is true. Therefore, yes. This point is on that line. Yes, this is a solution to the equation. Okay? Let's do the next one. Help me out. You guys do it. Plug it in. Yes or no? Yeah, it's a no. So we have 0 and 5. Right? And we have 5x minus 3y equals 15. What does x equal?
0.
What does y equal? 5. So we have 5 times 0 minus 3 times 5 equals 15. This cancels. I get negative 15 equals 15. Nope, that is not making my equation true, so it is not a solution to the equation. We clear?
Would you call that undefined or just no solution?
It's just, they're asking you the question, determine whether the given ordered pair is a solution of the equation. This one is yes, this one is no. Okay? Because if it makes it true, it's yes. If it's false, it's no. Cool? Okay? We're going to come back to that in just a minute. Why don't you go to the next page? So when you make your visual chart at the end of the chapter, you're going to go back to these sections and you're going to put things in basics, in graphing. So look at this. The top of this is called graphing. So all this would go in your graphing portion of your visual chart. Please look at this. There are 3 methods by which we can graph a line. Plug and chug, intercept, y equals mx plus b. When you take the test, you can use whatever method you want. But if there was a best method, or even just a method that I thought this will work, I wouldn't teach you 3, I would just teach you 1. But each method teaches you something valuable that others don't, that you must know. So we need to learn all 3 methods. So tonight, our emphasis is the plug and chug method. And in your homework, you are to use the plug and chug method. You are not to use other methods that you've learned elsewhere or at other times. And then the next section we'll do the intercept method, and it'll tell you just use the intercept method. And eventually we'll use the y equals mx plus b method, and you'll just do that method. And then on the test, you can use whatever you want. You good?
Yeah.
Okay. All right. Plug and chug method, 5 steps. Pick a value of x, plug it in the equation, chug out, solve for y. That gives you your first point. How many points do you need to graph a line? Solamente dos. Only 2, fetchers. Okay? 2. Okay? I want everybody to repeat after me. Everybody. What is a dot? 1 is a dot.
1 is a dot.
2 is a line.
2 is a line.
3 or more?
3 or more.
Waste of my time.
Waste of time.
Okay? So if you're being asked to graph a line, it's on the board. Okay? Look
Oh,
up
okay.
here.
I was tripping. I was like, what?
And I did make it up. Look up here. Years ago. I put a dot here. I put a dot here. I connect the dots. I'm done. Okay? If you're like, oh, I got another one. Oh, another one. Oh, here's one. And there's one. And there's one. You're wasting your fetching time. Okay? You only need 2 to connect the dots. And you got your line. 3 or more, waste of your time. You good?
Yep.
Okay. All right. So the plug and chug method. We're going to leave that up there. And just scroll down just ever so slightly so you can look at 2 pages at the same time. Can you look at 2 pages at the same time in your book, or do you have to turn the page?
Got to turn the page.
All right, so look it. We're going to do this, though, but we're going to have the steps up here, and you can be on the page where you need to write. So I'll leave the steps up there for you. Check it out. So we're being asked to graph the equation 2x plus 3y equals negative 6. 2x plus 3y equals negative 6. Now, do you need to buy graph paper?
Yeah.
No.
No.
Okay, if you want to or you like that and it makes you happy, you're all about it. Okay? All you gotta do, look up here, all you gotta do is go whoop, whoop, and just draw. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now most of you have lined paper, so you've already got the horizontal lines. So you can just put a vertical on there, and you can draw your axis and do that, okay? What I don't want to see on the homework, neither do the graders, they don't want to see you go, you know, okay? And yeah, don't do that, okay? It's just a mess,
I would do that now.
okay? You're gonna do that now? You're like my teenage kids, especially my sons now. Okay? Yeah, just draw it nice. Doesn't have to be perfect. Okay, there are slight discrepancies in sizes here, but it needs to be nice. Okay? All right. Here's the deal. First step says pick a value for x. So watch this. We're going to do 1, 2, 3, 4, 5. So number 1, I'm going to let x equal. I get to pick the value. You know, there's not a lot of things in life you get to pick. You can pick your nose. All right? You can pick your spouse. Right? Okay? And you can pick x. Okay? So what do you want x to equal right now? 40. Okay, so guess what? If you pick 40, you get to draw 40 hash marks across your graph. Okay? So you got to think about the level of work you want to do.
Let's do 4.
I'm seeing 1.
3.
Just do 2.
3.
Okay, so I'm going to let x equal 0. And I'm going to show you, okay, and you can pick, hey, you can pick whatever you want. But 0 is fast math. It's fast math. Watch what I'm talking about here. Step number 2 says we're going to plug it in. So where there's an x, we're going to put a 0. 2 times 0, I'm going to put these like this. 2 times 0 plus 3y equals negative 6. Do you see what I just did? Yes or no?
Yep.
I plugged 0 into this equation. That's step 2. It says up there, plug it in the equation. Chug out, that's why it's called plug and chug. Plug in a value, chug out the y value. Plug in an x value, chug out a y value. Okay, I'm going to chug out my value for y. So I'm going to solve for y. Okay? So I have 2 times 0 plus 3y equals negative 6. This cancels. I'm left with 3y. Do you see why the 0 is so powerful? Super fast math. 3y equals negative 6. Divide by 3. Divide by 3. I have my skills for my 3-step process to solving coming into play here, right? Y equals what?
2.
Negative 2. Okay? How many points do I have right now?
1.
Solamente uno, fechas. Yeah, only 1. How many do I need?
2.
Because 3 or more is a waste of my time, but I gotta have 2. Because 1 is a dot. Right now I just got a dot. Okay? And I put these together for my first point. 0, negative 2, right? They're an ordered pair. X coordinate, Y coordinate. I got 1 point. I have my first point. Step number 4, look. It says first point. See, I achieved my first point. Step number 4 says repeat the process to get the second point. So here we go. That's why I have more space for point number 4 here. Look up here. I'm going to let x equal. What do you want to let it equal?
1.
Okay, so here's the deal. Look at this. So now you've learned the power of small math, right? But here's the deal. If I draw a graph, look up here, please. If I draw a graph, and I have a value of x, see, there's a crappy graph. If I have a value of x and y, and I pick an x value of 1 or 0 and then 1, my two dots could be really close together. And my graph will be less accurate than if I have one here and maybe one out here. Now I can get it a little bit more accurate. So I want my math to be easy, but my second point, I want a little distance. Just a little. Okay? So let's go ahead and just say let x equal 2 in this instance. All right? So we'll say 2 times 2 plus 3y equals negative 6, right? Because I plugged this in for, the x value there, right? Right? 2x plus 3y equals negative 6 is my original. I plugged it in. Now I solve. I got 4 plus 3y equals negative 6. I subtract 4. I get 3y equals negative 10. I divide by 3, divide by 3. I get y equals negative 10/3. I can convert that to a decimal in this instance because I'm just graphing. I'm just using these to graph. So I could say that's negative 3 1/3 if I wanted to. Question, quickly.
Didn't you just find x again?
Didn't I just find x again?
Yeah.
No. I let x equal 2. I picked my value for x. I just repeated the process with a whole new value for x.
Oh,
Now,
yeah.
look at step number 5. Look up here. Step number 5. If you look at your stuff here, look at we just did step number 4. Step number 5. I gave you a graph. Okay, so you can graph it. I got to draw the graph here. Look up here, please. I have 0. So step number 5. Look at 5. It says plot the dots and connect them. Right. Look up here. I have 0 this way, negative 2. Is that my first point? Yes or no? Or is it here? Here or here? There. Okay. My next point is 1, 2, and negative 1, 2, 3, and about 1/3 right there. I connect them, and there's my line, and I'm done. I just graphed the equation 2x plus 3y equals negative 6. Okay, you cool? Okay. Listen. We're going to really quickly do the last problem and get you out of here. Okay? The last problem is 3x minus 4y equals negative 12. Now I want you guys to help me. 3x minus 4y equals negative 12. 3x minus 4y equals negative 12. What do you want to let x equal?
0.
I like 0 too. 3 times 0 minus 4y equals negative 12. This is gone. Negative 4y equals negative 12. Divide by negative 4. Divide by negative 4. And y equals positive 3. How many points do I have right now?
1.
How many do I need to graph a line?
2.
So I got to repeat the process. So I'm going to pick another value for x. What do you want to let x equal this time?
1.
Okay, let x equal 1. All right, we'll do that. 3 times 1 minus 4y equals negative 12. This is 3 minus 4y equals negative 12. I'm going to subtract 3. I get negative 4y equals negative 15. I divide by negative 4. I divide by negative 4. And I get y equals negative 15/4. Now, I want to share something with you, okay? This is going to be... negative 3.75 if you put it in a calculator. You can check that if you'd like. And the reason I'm making this in decimal is because I have to graph it. It's just going to make my graphing that much more precise, I guess. So now I draw a graph, right? 1, 2, 3, 4, 5. Brother Rich said you don't have to buy graph paper, but don't be a hot mess. Okay, just make it somewhat, legible and decent here. Okay, so we have 0, and then we go up 3. Agreed?
Yeah.
And then we have, on this one, we have 1 comma negative 3.75. So this is my first point, and this is my second point.
It's positive.
I'm sorry, it is positive because we divided each one by a negative. Thank you. Thank you. Okay, and so I have 1 and 1, 2, 3 and a quarter, so or something like that.
Wait,
And that's our line.
you go back one? Oh, I guess that's positive.
So we went 1 and 1, 2, 3.75-ish right in there.
Oh, okay.
So here's 2 quick questions at the end here. Look up here. Is a graph precise? Answer this. Is a graph precise?
Can't be.
I'll have to memorize this. We're gonna know later.
Yes.
Yes.
Look up here. If I asked you to tell me the coordinates of that point without doing any of the math, what would you say it is? That one right there.
4.
Yeah, it's not 4, is it? It's 3.75. Is it precise? No. A graph gives you a visual, okay, which is amazing. We are all visual learners, okay? So we like visuals, but it is not precise. What are the best numbers to pick for X for plug and chug? I'd say 0 and something close by, 1, 1, 2, or 3, right? So 0 and another small number. Okay. Why might you not want the X values super close together? Okay. Accuracy. All right. So look up here. We have these two right here, and if I was to draw that line, I could draw. Look at me. I could go like that. You know what I'm saying? I could go like that. I mean, it's just there's a lot of stuff. So if I have another dot out here that's further away, now I have greater accuracy. That's why maybe getting the second point a little further away than right next to it will give you better accuracy if you want to see it more precisely. Okay? You guys are awesome. Did everybody sign the roll? Anybody not? Okay. You guys have a good one, and we'll see you on Wednesday. Okay? Get your test done, and yeah, this is an easy homework assignment. See ya.